This is brought to you by the Alumni Association of PISJ-ES.
Gradient is basically slope of a line. It doesn't really have a definition in its term. What it really means, it's a relative quantity. What do you mean by a relative quantity? A relative quantity means that it is compared. It is a comparative quantity. For example, I have a line right here. I have a line right here. If a person, if for example this is a slide, and if I am sitting over here on this slide, this is me, and this is me again on the slide. Okay. So if a person sits on this slide, I think for all of us it would be completely alright. But if he sits on this slide, we'll tell him that this is dangerous. He will go like, okay, Adil, this is dangerous because this is too steep. This is too steep. It has a, it is, as in, it's, you can just slide here and you can just roll here like this and you can just fall. Why? Why is this dangerous? Because it is steeper. This one is steeper and this one is less steep. For example, I have another line here. This one. If a person is sitting here, you would say, oh, that's just, it's so babyish. It's nothing at all. So why? Because this is the steepest of all the three lines. This is a little less steeper than this one, and it's more steeper than this one. And it's steeper than this one, and this one is the least steep, or for example, less steepest. So this is what's going on here. So the steepness talks about the slope of a line. I can say that this line is steeper than all of the others, so it has a greater slope. However, this has a lesser slope and this has least slope because they are not as steep as this one. So the gradient talks about steepness of a line. This is the theory behind gradient. If a line is like this, it's the gradient will be more. Sorry about my retarded pen. So the gradient will be more compared to a line which has a slope like this, because this is steeper and this is less steep. So this will have a greater gradient because of the greater slope compared to this one. So it's a comparative quantity. Okay, this is gradient. This is the theory behind gradient. Now, how do we calculate gradient? For example, we have a line here. This is a graph here. For example, this is a distance time graph. This is meters here and this is time. You should always understand if this is a meter, this is a distance, and this is time. So it's a distance time graph. For example, if I have a line here, right here, and I ask you what is the slope of this line. The formula for the slope, and the slope is also denoted by an m, is change in the height or change in y divided by the change in x. For example, if this point is 4 and this lower point or the lowest point here is 1, and this point here is 1, and this point here is 4. So the formula says change in y divided by the change in corresponding x. You can also write this formula as y2 minus y1 divided by x2 minus x1. Now what does this mean? Let's talk about this point. I am assuming you would know how to take out coordinates of a graph. So this point has a coordinate of, if I write it like x and y, so this point, which I say point A has a coordinate of 1 on the x-axis from 0 and 4 on the y-axis. So this is point A. Let's talk about this point. This point B has a coordinate of 4 on the x-axis and 1 on the y-axis. So now the formula says y2 minus y1 over x2 minus x1. So first you will have to make sure which one is your 2 and which one is your 1. I am taking this as my point number 2 and this as my point number 1. So this value here, since this is the y value, this becomes y2 and this becomes x2, and this value here becomes y1 and this value here becomes x1. Now the formula says y2 minus y1 is equals to x2 minus x1. So let's just substitute. y2 is 1 minus 4 divided by x2 is 4 minus 1. So 1 minus 4, if you just use your calculator, would be minus 3 divided by 4 minus 1 is 3. So minus 3 divided by 3 is simply minus 1. So your gradient is minus 1. So we'll be doing more examples of gradient and we'll see how we will use gradient in our questions. So we'll be having one more video for gradients only, and then we will see how we will use this in our calculations. So if you have any queries, comment in the section below and I will reply to that. Thank you very much for watching.